Network Your Future Incorporated was very excited with the work we did on the IAM project. So they've asked us to come and be a consultant with them on a requirement that they have. The ask is to automate the creation of the VPC infrastructure, as their staff is familiar with manually creating the VPC services within AWS, but they have a mandate from the government to automate this process. The deadline is fast approaching, and they've only given us until tomorrow by close of business to come up with a solution for them. Now, taking a look at these requirements, we should be very familiar with the components. A single VPC with 4 subnets, one public and one private, and a pair of those, one in each availability zone. The 3 route tables, one public, where both public subnets will be associated with that, and 2 private route tables, one per availability zone, to go with the 2 NAT gateways and a single internet gateway. Just like their staff, we have experience manually configuring this inside of the AWS console, but this solution will tax our brains, as we're going to use an infrastructure as a code solution to rapidly deploy and create these resources inside of AWS. And not just that, but we'll also be able to tear down and destroy that via code. That deadline's fast approaching, so let's get to it. So we're already familiar with what goes into creating a VPC infrastructure in AWS. We know that we need a name and a CIDR block for our VPC, and we know what's needed to properly route traffic for both public and private subnets. So now, to meet our clients' requirements and take our game to the next level, we need to come up with a solution to automate that entire process. AWS offers an infrastructure as a code solution known as CloudFormation. Using templates that are formatted as text files, which often use either JSON or YAML format, you're able to start creating the blueprint for deploying AWS resources as code. And while not a bad option, if the client ever decided to move to another cloud provider, they would have to find another solution, since CloudFormation is written strictly for AWS. But on the other hand, HashiCorp's Terraform is an open source tool that allows us to automate infrastructure on any cloud provider's platform. The particulars of Terraform deserves a course of its own, but we will use this tool as our solution to the client, and I've already written the code that will meet their requirements. So let's take a quick peek before we demonstrate how easy it is to create and destroy a VPC infrastructure with this tool. We're going to use the Cloud Shell to download Terraform to simplify the execution of the code, but I'm going to actually use a visual editor program called Visual Studio Code to provide a quick overview. There are numerous ways to write code for the same solution, and it's possible to put all the code into a single file, but we've elected to break our code out into individual files that pertain to the specific functions of creating a VPC infrastructure. So let me quickly provide a high-level overview of what our code will be doing. Terraform files have an extension of .tf, and our main Terraform file here simply specifies the region that our code is going to deploy in, which is the US East 1. But of particular note also is this provider AWS. Currently, Terraform supports over 130 providers other than AWS, but this is where it knows how to go down and pull the appropriate plugins and modules for each of those providers. So if our client ever decided, for instance, to move to Azure, they'd simply need to change this provider to Azure, and they'd be able to use all of this code. So heading down to the VPC file, which we're very familiar with, this resource, which is the AWS VPC, has a local identifier that we've chosen to give it VPC. We could have chosen any name such as ice cream or ABC123, but what this local identifier does is if we need to reference this anywhere in the code, it's easier to make this a name that you definitely can easily know what its use is. For the CIDR block, we are using a variable named VPC CIDR. So if we go to the variables file, here we see 5 different variables that have no value. The values are actually stored in the only file that ends in .tf vars, and this is where the values for the variables are contained. And so this is where we see for the VPC CIDR variable, the specific value of 10.100.0.0/16. So when we run this Terraform code here in just a few minutes, we're going to see that this is the CIDR that it's going to create for the VPC. And again, we're using the tag to apply the name right here. But going back to that TFRs, we see the other 4 are, of course, for the 4 different subnets. And you probably could have guessed that by taking a look at this. So let's go ahead and head on over to the subnets. Here on the subnets, this again is the resource, but instead of AWS VPC, it's AWS subnet. And of course, a different local identifier, pub sub 1 and pub sub 2, again, sub for subnet. So these are our 2 subnet resources that are going to be created. And again, the CIDR block, this is that variable with the name that we just saw, and the VPC ID. This is the specific attribute from that AWS VPC resource and the VPC, that local identifier. Now for the availability zones, we see here that the availability zones data source, which allows access to the list of AWS availability zones so that our code can access the specific region within the AWS account to pull down the specific AZs for that region, because counter to popular belief, each of the regions are not, identified as 1A, 1B, 1C, 1D. Some of the regions, their availability zones are like 2A or 2G. So this is how our code knows to get the right one. And for the first public subnet, we see that it's going to use an index value of 0, which is actually the first one of 1A in the console. And likewise, for the second public subnet, the index is 1, which corresponds to the second AZ in US East 1, which is 1B. Now, this method of counting starting at 0 for the first value, it's referred to as counting canonically. So if we come down just a little bit, the same type of code is used for the private subnets. Next up, we're going to take a look at the gateways. And here for our gateways, we see that we start off with the resource of EIP, or those elastic IP addresses that the NAT gateways need. So we're reserving those. And because we're going to need 2 NAT gateways, we need to give them uniquely identified names. One is NAT1, one is NAT2. And down here, when we're creating those NAT gateways, again, this is where we're referencing the first elastic IP for NAT1 to basically make the proper association to the first NAT gateway. And likewise, for the second NAT gateway, we're using the second elastic IP that we made up there. And then this depends on line. There's certain things that need to happen in certain order. If there was something in the code while it was building it out that needed to wait, there may be timeouts and retries. But if you already know of those dependencies, using this depends on this NAT gateway building it, it'll wait until the internet gateway is built. So that's what that's doing right there. And of course, this resource is going to deploy the internet gateway. Last but not least, of course, my favorite part is the route tables. So for our public route table, we see that the destination is all zeros, which again matches all traffic. And the target is going to be the internet gateway. And down here, these 2 blocks of code are going to tie the 2 public subnets or associate them with that route table. And again, using that naming convention that we just saw, of course, the resource, the local identifier, and then it needs to get that specific ID to tie everything together. Now for the private route tables, as we saw in the last lesson while we were building them out, similar to the public route tables, the destination is still going to match all traffic, the quad 0. But instead of being routing it or targeting it to the internet gateway, these, of course, will be targeting the NAT gateway. And so for the first private route table, it's going to target NAT gateway 1, which is in AZ1A. And for the second private subnet, it's going to target the second NAT gateway that's in AZ1B. And when we deploy it and create it, this will be the last thing or resource that gets deployed. We're going to check to make sure these IDs are different. And likewise, the final thing is associating each of those subnets to the proper route table. And it's basically route table 1 for the private is going to be tied to subnet private 1. And of course, same for subnet private 2, private subnet 2, I should say, and the second private route table. So that again is pretty much a high level overview of our code. And it's definitely a lot to take in. And like I said earlier, learning and teaching Terraform truly deserves a course of its own, but I wouldn't have felt right not going over the code for our solution. So I definitely hope you found value in this, and it's almost time to basically demonstrate our solution. So for that, let's go ahead and head on over to the AWS console. So from our AWS console session, we need to, of course, activate our Cloud Shell session. So let's click on this icon here. And let's go ahead and let that load, because we're going to need to download, of course, our Terraform. So let me, while that's loading, get those lines of code. You can find these in your resources. So I'm going to paste these in right here. Those are the lines there. And that, again, is basically installing Terraform here in our Cloud Shell in our home directory. These lines are kind of making a symbiotic link so that if we got out of a session, came back in, it makes sure that this bin directory, that all of our variables for this environment are consistent and we don't lose anything. And we're specifying the specific version of 1.2.5 here, which we know works with our code. So again, likewise, let's go ahead and download that zip file, which basically when we unzip it, there we go. Sorry. All right. So there we go. So now to unzip that, just simply type unzip and then the file name. We'll tab that to complete. And now if we do a ls, we see both here. Let's do a little bit of cleanup. We'll do a rm to remove that zip file. Let's do a .zip. And now we just see our directory, which we need to go into. So cd to change into that directory. And then there we go. And if we do a ls, these are, again, those TF files, and of course that single TF vars that we just went over or saw in Visual Studio Code. So this is our code, and it's now time to basically let the drum roll and do the magic. But before we do that, I'd like to ask, or I'll do it on my screen, and if you're following along, hit services or click on services, right click on VPC and open this in a new tab. We actually want to see the elements or the components being built right as we're running our code. So let's go ahead and do that. And here we go. So let's wait for our VPC. We're going to do this live, no skipping ahead, no fast forwarding, no editing, no magic. Actually want to talk this through in real time along with when we do the destruction. So one thing to note here as well, let's see. But let's go ahead and clear our screen. And I did skip a command that was that copy paste issue from earlier. This TF environment use 1.2.5. And this is going to set the specific version to use there. So now we're actually ready to run our Terraform code. So let's go ahead and do a Terraform init. And this is going to initialize our environment and basically download the required plugins. And our provider, of course, is AWS. So again, online, it's going to download the trusted plugins that it needs to run the code. And as you can see, we have successfully initialized this. So now if we were to do an ls, this again is just getting a little bit ahead of the curve outside of the requirements, but we now will run a Terraform plan. And this is going to output a plan and tell us, the cloud administrator, on what it's getting ready to deploy. If we were to, of course, apply these changes, you'll see in a lot of these sections, it tells us that this value will be known after the apply. And that's because there's certain things like when you create the NAT gateway, we saw that in the console when we did it here manually. It took a while to finish getting built, the state to go to kind of complete or available. So you won't know the IDs or different things until it's fully done. But just scrolling up here to take a look at everything there. So now that we have our plan, we see that 17 different resources or components are going to be run. Let me do an ls again. There we go. So we don't have our state file yet, just showing you that we don't have that. But now it's time to run a Terraform apply. If we do a Terraform apply without the -- auto - approve, it's going to ask us, are we sure? So here again, it's going to display the same thing, and it's going to prompt us to type yes to auto approve. So now we're going to click that, and it's off to the races. It's creating. We see if we can read fast enough the VPCs first, and then those elastic IPs. So if we refresh the VPC again, this is going to be live, no fast forwarding or anything like that. We see that our VPC is already created. And when we were explaining the variables files, we said to remember, this is the CIDR block that we're going to use for this VPC. NAT gateways are being created. Those again will take a while. We got our route tables there. And of course the internet gateway, because we saw that the NAT gateway depend on that being created first. So if we were to go to our subnets, because when we manually created our NAT gateway, we saw that the two different parameters in the route table is the destination and the target, but we cannot pick our NAT gateway 1 and 2 as a target until they're actually fully created. So that's what we're going to be waiting on there. But we see the 4 subnets. But like I just explained for the route table, if we sort here, we see that the public route table is already done. And because the internet gateway is created, if we click on this, we see that both subnets are associated and the destination for that is all zeros in the target of the internet gateway. So now it's really just waiting for the NAT gateways to be created. And again, as we see here, we have 2 that are pending. Again, so once those are done, we're going to basically pretty much be ready. But let's see. We'll have to wait on those. So let's refresh. So we see that our first one is available. So if we click on that, we know the second one should be right behind it. So it's probably finishing up here in just a few seconds. Let's see, 1:50. Maybe we can get this done in under 2 minutes. Might be a record. Did a test run here for these earlier. This took about 2 minutes and 36 seconds to complete. But let me refresh and see. So both NAT gateways are available. So let's see. All right. So let's go back to the route table there. And we see that we have our private 1A and subnet association is going to be with .2. Again, destination for all will point to this NAT gateway. And like we said, this target ends in BD7. And so we should have a different identifier for our second NAT gateway. And this one ends in A39. So again, everything is looking good here. We're just waiting on the code to tell us that it's done creating all 17 resources. And I expect that to be here very, very soon. But let's see, subnets, VPC, route table, internet gateway, and that should be about it. Let's see, let's go back here. A and B, NAT gateway. All right. Minute 40. But yeah, this is definitely pretty amazing to be able to Learn the logic of the code, and as long as you start to understand the elements or the attributes that go into each of the different components, it makes it a little bit easier to understand. So that's why sometimes going the long route first and learning and understanding how to create, for example, the VPC infrastructure entirely through the console manually, almost a crawl before you walk type of state. It should make reading and understanding the Terraform code just a little bit easier than if you came into a little bit blind. So that's all that is. But not sure what's happening here in the code. We have everything created, so let's see what it's trying to do. It's finished up there. I don't know if it was tightening up something in the background. May have been 2 minutes and 40 seconds, but again, it looks like all 17 of those were created. And you saw me earlier looking for this state file, but making sure that it wasn't listed yet. So now when we do an ls back in our code, we do see that we have this terraform.tf state. And the amazing thing about Terraform as a code is not only does it keep track of the resources that are created, but it also keeps track of those that are destroyed. And so it has kind of a versioning component so that if we were to come in here, because there are flags where we can put in our code to say, destroy just one NAT gateway. And so if it destroyed that and all of its components, the next time we ran Terraform, it wouldn't deploy all 17 resources. It would look at this state file and compare it to the desired state and say, hey, I need to, everything for NAT gateway 1 is still there. So I just need to rebuild the NAT 2 and its components. But if we do a cat, and we do Terraform TF state, we're going to now basically be able to see that this file is showing the resources that it created and it's managing right now. And if you were to go in here, it's basically all of the attributes that are possible for each of those resources. So pretty cool there, but you know, it's basically amazing to be able to do that. So now it's really time to destroy this infrastructure. And so again, we're going to do the opposite, but let's do Terraform destroy. And then we're going to do this time, the -- auto approve. And we're going to destroy these resources programmatically or via code. So this is that second part of the requirement. We, of course, just demonstrated that we created the entire VPC infrastructure that's needed per their requirements. And so now we're doing the second part, like we said, which is to demonstrate that we can destroy that infrastructure via code. So pretty amazing. This one, we're just going to wait for it to say finish before we do any refreshes here. But the last thing that it will destroy is going to be the VPC. Kind of backwards. It was the first thing that it created. So, you know, that which is first shall be last. So let's see, we'll wait just a little bit more, but let's see. If I had to take a guess, these NAT gateways are, well, I don't even have to guess. We can read the description here and kind of get a guess of what's happening. It's messing with these elastic IPs. NAT gateway still destroying. Let's take a look there. So all 4 deleted. Again, 2 that we did a dry run or a test run right before this. So it's gone ahead and destroyed all 17 resources. So again, subnets are no longer here. And the internet gateway. And of course, no route table for those. And just back to 2 VPC. So again, we just demonstrated how we could, via code, maintain, deploy, manage, and of course, destroy VPC infrastructure. And just to demonstrate here, we just saw that we listed all the components of the resources, but now it's basically empty. So amazing job. Super proud of you. And we can see not only And we can see now not only what's possible in the cloud, but how we can continue to elevate ourselves and continue to layer different things that we're learning on one another to continue to take it to the next level. So this is just the start. Again, up in our next module, we're going to now be deploying servers so we can get familiar with actually logging into servers, running different codes, websites, and things like that. So this was the fundamentals of the networking piece. This is what's needed to basically establish the routes and to make sure that when we deploy our servers that they know how to get to the internet and basically how to receive traffic from the internet. So again, great job. Our client is going to be very happy with this as well. So continue to do great work, and there's definitely more to do. So I'll see you in the next video. Oh man, I hope you enjoyed that video. And if you did, then I got a surprise for you right now. That's actually just one video in the 7-day AWS Accelerator Bootcamp. That's right. Tonight, I'm going to actually launch my very first course, and I'm super excited. And if you want to find out more information, how you can transform yourself and take yourself from zero to hero in just 7 days, regardless of where you are, you don't need any previous technical skills. As long as you know how to operate a phone or a computer, then I'll take you the rest of the way. So if you're ready to network your future, then click the link down below and learn more about this program. But until next time, stay safe, take care of yourselves. Peace.